many molecules of water are there in Lake Erie? That's the answer to the question that you're going to try to find out today. Now, if you have not already read through experiment 1A, the lab that I sent you, you need to pause the video, you need to go get the lab, and you need to read through it before you watch the rest of this video, because I'm going to try to give you a little helpful advice on how to start this lab. If you have already read through it, you may be thinking, oh my gosh, what did I just get myself into when I signed up for this class? This does not look easy. First of all, don't panic. You got this. You can do this. I have all the confidence in the world in you. The purpose of this lab is to give you more practice with dimensional analysis, which is what we did in the problem sets yesterday. We were converting from this unit to that unit. We were converting from grams per milliliter to moles per liter. We were converting from cubic centimeters to cubic meters. And so this experiment has everything to do with dimensional analysis. And you're going to be able to answer this question by using dimensional analysis along with the tools that I told you to use. Okay, so first of all, keep that in mind. Dimensional analysis is all about relationships, and it's about converting from one unit to another unit. Okay, now, there were 3 specific tools that I told you that you would be able to use. I told you to use an eyedropper. I told you that you could use a graduated cylinder. And I told you that you could use a mass balance. Okay, well, why would I tell you to use those things? Well, first of all, let's think about what can you measure using these things? And then you're allowed to use water too, of course. And so what can you measure using these particular tools? Well, with the mass balance, should be obvious that you're going to be able to measure mass, and your mass is going to be measured in grams. If you're using a graduated cylinder, you're going to be able to measure a volume in milliliters. Why would I tell you to use an eyedropper? Why would that be important? Well, I want you to think back to the titration that you did in first year chemistry. You had to measure volume very, very accurately, because when you added 1 drop of either acid or base, that can make your indicator change color. How did you measure those volumes very, very, very accurately? Try to think back and remember, how did you get to exactly 50 milliliters? If you were trying to add exactly 50 milliliters of something, if you were trying to add exactly 20 milliliters that you were going to use in a titration, how exactly did you get it so that it was as precise a volume measurement as you could possibly do, okay? If not, you could even pull your old book out and go, okay, what was I doing there with an eyedropper and a graduated cylinder to try to measure my volumes exceedingly accurately? Because we're going to have to do some very accurate measurement here, some very precise measurement when we're talking about molecules, right? Okay, so what are you going to do with the eyedropper? With these 3 tools, you will be able to measure 3 things. So with an eyedropper, you can measure the number of drops in something, should you decide you want to do that. What relationship can you establish between these 3 things? What relationships can you establish between milliliters of water and grams of water? What relationships can you establish between milliliters of water and how many drops that might potentially be? What relationship can you establish between the number of drops of water and a gram of water? Okay, those are just some ideas to throw out to you, but you need to be able to establish relationships between those 3 items. And with those relationships, along with the information I gave you, which I believe I gave you the fact that 1 mole of anything is 6.02 times 10 to the 23rd units of anything. That should be something that hopefully you remembered, but if not, that information is there for you. I told you that 1 mole of water is 18.02 grams. Again, something that you could have figured out from the periodic table, but I threw that in there for you. I gave you the average depth of Lake Erie, and I gave you the area of Lake Erie. With those 4 pieces of information, with these 3 tools and the relationships that you can establish between these three types of measurements of water, you will be able to use dimensional analysis to start making conversions from a huge volume of Lake Erie all the way down to the number of molecules. So that's the goal here. That's the whole purpose of doing this. If you are really stuck, and now I don't mean think about it for 2 minutes and then decide you're stuck. That's not stuck, okay? But if you have worked and worked and worked and you are really struggling, email me and ask me, and I'll try to give you a hint. But I want you to see if you can figure this out on your own. Again, I have full confidence in you, and I think you can do this. So have fun figuring out how many molecules there are in Lake Erie.